A black janitor's son thinks he can save a $500 million system? That's hilarious. Tech Vantage Industries, Seattle. 200 investors watching the Apex 8 demonstration. Disaster strikes. The system explodes. Sparks rain. Metal screams. Alarms shriek. Assembly line collapses. Richard Whitmore, CEO, watches his empire crumble. Hands shaking, sweating. 6 hours of failures. Engineers stumped. Consultants quit. 48 hours until bankruptcy. Samuel Underwood steps forward from maintenance. Young, black, mother's housekeeping tag on his chest. Tablet in hand. Whitmore storms over, rips the tablet, hurls it at the wall. Glass shatters. Your mama scrubs toilets. That's all you black people are worth. Shoves Samuel backward. Stay in your place, boy, before I throw your mama on the street. Whitmore just destroyed his only salvation because of racism. That young black man knows how to save everything. In 48 hours, Whitmore loses his empire while Samuel proves genius beats prejudice. Keep watching. This gets wild. Let's rewind 12 hours before that humiliation. Tech Vantage Industries wasn't always on the edge of collapse. Yesterday, this company was the darling of Wall Street. Their Apex 8 robotic assembly system was supposed to revolutionize manufacturing. Automotive companies, aerospace contractors, everyone wanted it. The system was brilliant. 6 robotic arms working in perfect synchronization, AI-driven precision down to 2 microns, quantum sensors detecting microscopic defects. It could assemble a turbofan engine component in 43 minutes, a task that normally took human workers 6 hours. Richard Whitmore built this company from nothing. Started in a garage 20 years ago, grew it into a $900 million empire. This demonstration was his crowning achievement. The moment that would secure $2 billion in funding and cement his legacy. 200 investors flew in from across the country. CEOs, venture capitalists, industry analysts, media from TechCrunch, Bloomberg, Wired. This wasn't just a product demo. This was Richard Whitmore's coronation. The demonstration started at 9 a.m. sharp. Whitmore stood at the podium wearing his best suit, confident, beaming. Ladies and gentlemen, what you're about to witness will change the future of American manufacturing forever. The system powered up. Robotic arms extended smoothly, sensors activated. The AI came online with a soft hum. Everything looked perfect. They loaded the test component, a complex turbofan engine part with 132 precision points, the kind that required absolute perfection. The Apex 8 began its work. Minute 1, minute 5, minute 10. The investors leaned forward. Cameras zoomed in. Everything was flawless. Minute 20, minute 30. Minute 40, then minute 43, a sound, barely audible at first, a high-pitched whine from deep inside the main coupling assembly. Whitmore's smile faltered. His head engineer, Christopher Davis, stepped closer to the control panel. His face went pale. "Sir, we're seeing unusual vibration readings." Whitmore waved him off. "It's within normal parameters." But the whine got louder, higher-pitched, almost ultrasonic. Then the sparks started, small at first, just tiny flashes, but within seconds they multiplied, orange sparks showering down like deadly fireworks. The robotic arms began shaking, violently, like being torn apart from the inside. Alarms started blaring, red warning lights flooded the floor. Christopher Davis shouted into his headset, "Emergency shutdown, now!" But the system didn't respond. The AI had frozen. The robotic arms continued their violent shaking. Metal began to scream. Then the main coupling assembly exploded. Not a small failure. A catastrophic structural collapse. The coupling unit shattered. Metal fragments flew. Smoke billowed. Every alarm in the building shrieked. The entire $500 million line went dead. Total system failure. The demonstration hall fell silent. 200 investors sat frozen. Media cameras kept rolling, capturing every second. Whitmore stood at the podium, his face completely white. His hands gripped the edges so hard his knuckles turned bone white. Christopher Davis and his team swarmed the system. Tablets out, diagnostic equipment connected. They ran every test they knew. Hour 1 passed, no diagnosis. Hour 2, still nothing. Whitmore brought in external consultants, 3 engineering firms on emergency contracts, $250,000 in fees. They examined the system for 3 hours. Their conclusion? Catastrophic mechanical failure, unknown root cause, estimated repair time 2 to 3 weeks minimum, requires complete disassembly, 2 to 3 weeks. The investors gave him 48 hours or they'd walk. $2 billion would vanish. Without that funding, TechVantage couldn't meet payroll. The company would collapse into bankruptcy. Hour 6. Whitmore was desperate. He called the retired founder who originally designed the coupling system, flew him in on a private jet. The founder spent 3 hours examining diagnostics and schematics. Finally, he looked up with tired eyes. "Richard, something is fundamentally wrong with the force distribution. The failure pattern doesn't make sense. I can't pinpoint it without complete disassembly. That would take a week minimum." They didn't have a week. They had 48 hours. Whitmore stood in the observation deck overlooking the dead assembly line. His company, his life's work, 20 years of effort, all of it dying. That's when he saw him. Samuel Underwood, night shift maintenance worker, standing on the walkway above the demonstration floor, looking down at the system. Holding a tablet, Samuel had been there the whole time. Quiet, invisible, just another maintenance worker nobody paid attention to. But he'd been watching, studying. His eyes moved across the system with intense focus. He saw something. Whitmore could tell, the way Samuel's eyes narrowed, the way he made notes, the way he kept looking at one specific section of the coupling assembly. Samuel started walking toward the stairs, coming down to the demonstration floor, his maintenance uniform marked with grease stains, his mother's housekeeping name tag still pinned to his chest. He approached the control area. His voice was quiet but steady. "Mr. Whitmore, I think I know what's wrong with the system." That's when everything changed. Whitmore turned, saw Samuel, saw the maintenance uniform, saw the black skin, saw his mother's housekeeping name tag. And something inside Whitmore snapped. All his desperation, all his fear, all his rage. It focused on this one moment. This one person who dared to think he could help. A black janitor's son, trying to tell him how to fix a $500 million system that MIT-educated engineers couldn't diagnose. The fury was instant, overwhelming. A black janitor's son thinks he can save a $500 million system? That's hilarious. He stormed across the floor, ripped the tablet from Samuel's hands, hurled it against the concrete wall. The device exploded into fragments. "Your mama scrubs toilets, that's all you black people are worth." He shoved Samuel backward, hard enough to make him stumble. "Stay in your place, boy, before I throw your mama on the street." Christopher Davis stepped forward, uncomfortable. "Sir, maybe we should at least look at—" "No." Whitmore's voice was ice. "Get him out. Security." 2 security guards appeared. They escorted Samuel away. His hands were still raised, still trying to explain, but nobody was listening. They took him to the maintenance break room, told him to stay there, away from crisis operations. Samuel sat alone, his shattered tablet in pieces, his data, his months of observations, his solution, all dismissed in 30 seconds. He pulled out his personal phone, opened his notes app, started writing everything from memory, every observation, every calculation, every piece of the solution, because Samuel knew something nobody else understood. The system wasn't failing because of a mechanical defect. It was failing because of a timing mismatch between the AI control systems and mechanical stress responses, a harmonic resonance pattern that built at specific torque loads. He'd seen it before, in his father's garage, rebuilding engines that failed exactly the same way. He knew how to fix it. The solution was simple: 90 minutes of work, software recalibration, minor mechanical adjustments. But nobody would listen to the black maintenance worker. Back on the demonstration floor, hours continued ticking away. Hour 12, hour 18, hour 24. Investors grew impatient. Media reported the crisis. TechVantage stock dropped 34% in one day. Major clients started making concerned calls. Whitmore tried everything. More consultants, more diagnostics. His engineers worked through the night, testing, retesting, finding nothing. Hour 36 arrived. 12 hours left until the investor deadline. That's when Whitmore made one final call. Dr. Elena Vasquez. She was a legend in robotics. 52 years old, brilliant, uncompromising. Designed systems for 3 Fortune 100 companies. Held 52 patents. Advised NASA on Mars rover assembly. If anyone could solve this, it was her. Her consulting fee? $150,000. Whitmore didn't hesitate. He wired the money immediately. Dr. Vasquez arrived 6 hours later. She walked onto the demonstration floor wearing jeans and a leather jacket. No corporate polish, just raw competence. She spent 30 minutes examining the system, reading diagnostic reports, asking pointed questions that made engineers uncomfortable. Then she turned to Whitmore. "I need to speak with everyone who's interacted with this system, not just engineers. Everyone." Whitmore frowned. "Dr. Vasquez, we don't have time for Mr. Whitmore." Her voice was steel. "In 30 years of solving impossible problems, I've learned that solutions come from unexpected places. You hired me for my expertise. Trust it, or I'm on the next flight out." Whitmore had no choice. Out of options, out of time, out of hope. "Fine, do it your way." Dr. Vasquez looked at the security chief. "Gather everyone. Engineers, maintenance, operations, administrative staff, anyone who's been in this building during system operations." 40 minutes later, 85 people gathered on the demonstration floor. Dr. Vasquez stood before them. Her eyes swept across the crowd, taking in every face, every uniform, every level of the hierarchy. And in the back, standing with the maintenance crew, was Samuel Underwood, still wearing his uniform, still carrying his mother's name tag, still holding his phone with all his notes. Dr. Vasquez was about to do something that would change everything. She was about to give voice to the voiceless. Want to see someone finally listen? Hit that like button, because what happens next will restore your faith in humanity. Before we see what happens next, you need to understand where Samuel's gift came from. Rewind 22 years. A small apartment in South Seattle. A boy named Samuel and his father, Thomas Underwood. Thomas was a diesel mechanic for Metro Transit Authority. Never went to college, never had formal engineering training. Everything he knew came from military motor pools and 20 years of keeping city buses running. But Thomas understood machines in a way that most engineers never would. He could hear problems, feel them, diagnose issues that computer diagnostics missed. Their garage became Samuel's classroom. From age 8, Samuel spent every weekend rebuilding engines with his father. Diesel truck engines from salvage yards, motorcycle engines from estate sales. Once, they even rebuilt a vintage aircraft engine Thomas bought from a closed museum. Thomas didn't teach from textbooks. He taught through observation, through feel, through intuition. Close your eyes, Samuel. Listen to where the friction is. Metal talks to you if you pay attention. See how this gear tooth is worn slightly on one edge? That tells a story about load distribution. Engines are honest. They never lie about what's wrong. People lie. Engineers lie in their reports, but the metal tells the truth. When Samuel was 14, something happened that changed everything. A metro bus kept stalling randomly, only during specific weather conditions. The depot mechanics had been working on it for 3 weeks. They'd replaced fuel injectors, computer systems, sensors, $18,000 in parts. Nothing worked. Thomas brought Samuel to look at it one Saturday. Samuel walked around the bus for 20 minutes, listening, observing, thinking. Then he noticed something. Condensation patterns in the air intake manifold. During high humidity, microscopic moisture collected in a specific chamber. It disrupted the air-fuel ratio at precise temperature and pressure combinations. The solution? A $40 modified breather valve and intake rerouting. The depot chief tried to give Thomas credit. Thomas refused. This was Samuel. Give him the recognition. 3 weeks later, Thomas was diagnosed with stage 4 pancreatic cancer. He had 9 months to live. He died 2 weeks after Samuel's 16th birthday. His final words to Samuel: "You see things others don't because you listen to what the work tells you, not what people tell you to see. Don't let anyone make you forget that." After Thomas died, everything became harder. Samuel's grades dropped from a 3.8 to a 2.9 during junior year. College acceptance letters were thin. Financial aid wasn't enough. He attended community college part-time, worked retail, then maintenance jobs, applied to engineering programs. But without credentials, without connections, without the right resume, doors stayed closed. His mother Margaret worked double shifts to keep them afloat. Samuel watched her clean offices where executives made more in a day than she made in a month. But Thomas had left Samuel something more valuable than money: a principle, a way of seeing the world. The work speaks louder than the title. Listen to the work. That became Samuel's operating principle. When supervisors dismissed his reports, he kept documenting observations anyway. When locked out of technical areas, he studied manuals during breaks. When told he wasn't qualified, he taught himself through MIT OpenCourseWare. Over 14 months at TechVantage, Samuel became a ghost, invisible to management. But he saw everything. He learned everything. He memorized the complete Apex 8 technical specification, all 1,238 pages, created personal diagnostic journals of every anomaly he observed, built a home workshop where he replicated key Apex 8 mechanical assemblies using 3D printed parts and salvaged components. He studied quantum sensing theory through free university courses, taught himself advanced materials science, learned Python programming and tensor mathematics. He knew this system better than most engineers on staff, not because he had access, but because he was invisible enough to observe everything without being watched. 6 months ago, Samuel submitted a maintenance report. Unusual harmonic vibration in coupling assembly C4 during high-torque operations. The engineering supervisor, Bradley Hammond, crumpled it without reading. Stick to mopping floors. We have MIT graduates handling diagnostics. 3 months ago, Samuel was escorted out of the engineering bay by security for reading technical manuals during his break. Whitmore witnessed it personally. These manuals are for qualified personnel. If I catch you in restricted areas again, you're terminated. 2 weeks ago, Samuel noticed anomalous heat signatures in the main coupling unit. He emailed senior engineer Dr. Rebecca Morrison with thermal imagery from his personal infrared thermometer. The response? Automated rejection. His email was flagged as spam from unauthorized personnel. Then came the worst moment. Samuel approached Whitmore in the executive parking garage to hand-deliver a technical analysis. Whitmore looked at Samuel's maintenance uniform, saw his mother emptying a nearby waste bin. Like mother, like son. Know your ceiling. That's your bloodline. He drove away without reading a word, but Samuel never stopped watching, never stopped learning, never stopped documenting, because his father taught him that the work speaks for itself. And Samuel believed that truth would find a way, even when nobody was listening, even when nobody cared, even when he was treated like he was invisible. The work would speak. Eventually, someone would hear it. That someone was about to walk into the room. Dr. Elena Vasquez stands at the center of the demonstration floor. 85 people surround her in a loose circle. Engineers in their company polo shirts, operations staff in business casual, maintenance crew in their work uniforms. Samuel stands in the back with the other maintenance workers. His heart is pounding. He knows this is it. His last chance. Maybe his only chance. Dr. Vasquez's voice cuts through the nervous murmur. I'm going to be direct. This system is failing in a way nobody fully understands. Your top engineers can't diagnose it. External consultants quit. You have 11 hours left before this company collapses. She pauses. Lets that sink in. I've spent 30 years solving impossible problems, and I've learned something important. Solutions don't always come from the expected places. They come from the people who actually see the problem. She looks around the circle, making eye contact with different people. I want to hear from anyone who's observed anything unusual. Sounds, vibrations, patterns, thermal anomalies, anything. Christopher Davis steps forward first. He's the head engineer, his responsibility, his failure. Dr. Vasquez, we've run comprehensive diagnostics, thermal analysis, stress testing. The data points to mechanical failure in the coupling assembly, likely a manufacturing defect. But we can't identify the specific failure mechanism without full disassembly. Dr. Vasquez nods. But you can't disassemble in 11 hours. No, we'd need at least a week. She turns to the external consultants. They give similar assessments. Manufacturing defect, unknown specific cause, requires extensive investigation. Dr. Vasquez's expression doesn't change. So everyone agrees the coupling is failing, but nobody knows why. The operations manager raises his hand. Middle-aged guy named Thompson. We've been reporting unusual vibration patterns for 3 months during high-torque cycles. We submitted multiple reports to engineering. Dr. Vasquez turns to Christopher Davis. And? Christopher shifts uncomfortably. We reviewed the reports. Vibration levels were within acceptable operational parameters according to our specifications. But they were unusual? Yes, but not outside safety margins. Dr. Vasquez nods slowly. So you had warning signs. You dismissed them because they were technically within spec. The room gets uncomfortable. Engineers exchange glances. This is hitting too close. Doctor, Vasquez turns to the broader group. Anyone else notice patterns? A maintenance supervisor named Jamal speaks up. He's been with the company 8 years. The system sounds different during overnight diagnostic cycles. When the building is quiet, you can hear things the day shift doesn't. Different how? Like there's a rhythm to it, not random, almost musical. Frequencies building on each other. Dr. Vasquez's eyes sharpen. That's harmonic resonance. Anyone else hear this? Silence. Then slowly, Samuel's hand rises. Every head in the room turns. People see the maintenance uniform, see his mother's housekeeping name tag. Some people recognize him from earlier, when Whitmore threw him out. Dr. Vasquez locks eyes with him. Your name? Samuel Underwood, night shift maintenance. From the observation deck above, Whitmore's voice cuts through. Dr. Vasquez, we really don't have time to... She doesn't even look up, just raises one hand. The gesture is so commanding that Whitmore actually stops talking. Mr. Underwood, what have you observed? Samuel takes a breath. His voice is quiet but steady. The system is experiencing destructive harmonic interference between the AI control pulse frequency and the mechanical stress cycles. The coupling isn't failing because of a defect. It's being torn apart by resonance waves that build at specific torque loads. The room goes completely silent. Christopher Davis frowns. That's a very complex diagnosis. What's your engineering background? I don't have one. I work maintenance. Murmurs ripple through the engineers, some dismissive, some curious. Bradley Hammond, the supervisor who dismissed Samuel's reports, scoffs loudly. With all due respect, Dr. Vasquez, we've had teams of qualified engineers analyzing this system for 6 hours. This is a maintenance worker. He pushes a mop. Dr. Vasquez turns to him. Her voice is ice. I decide what's qualified. Mr. Underwood, explain your reasoning. Samuel steps forward. His hands are shaking slightly, but his voice stays steady. I've been documenting anomalies for 6 months. The vibration patterns Thompson mentioned, they started appearing when the system operated at 11,000 to 13,000 Newton meters of torque. That's the range where the mechanical response frequency naturally shifts to match the AI control frequency. He pulls out his phone, opens his notes. The Apex 8 AI samples positional data and sends correction pulses at 400 Hz. At 12,500 Newton meters of torque, the coupling assembly oscillates at approximately 400 Hz due to its material properties and geometric configuration. Dr. Rebecca Morrison, a senior engineer, leans forward. You're saying the AI and the mechanical system are synchronizing? Exactly. When the frequencies align, you get constructive interference. Each AI pulse amplifies the mechanical vibration. Each vibration cycle feeds back into the quantum sensors. The AI interprets this as a position error and sends more correction pulses, which makes it worse. It's a feedback loop that builds exponentially. Emma Wilson, the mechanical engineer, is studying Samuel with new intensity. That would explain why the failure happened at minute 43. That's exactly how long it would take for the resonance to build to catastrophic levels. Bradley Hammond isn't backing down. This is theoretical speculation from someone with zero credentials. We need concrete proof. Dr. Vasquez looks at Samuel. Do you have proof? Samuel nods. He scrolls through his phone. I've been collecting thermal imagery during night shifts, using a personal infrared thermometer. The heat buildup patterns in the coupling assembly correlate exactly with the predicted resonance zones. He holds up his phone. Shows a series of thermal images with timestamps and temperature readings. I also recorded vibration data using my phone's accelerometer during diagnostic cycles. The frequency patterns show clear harmonic buildup toward the 400 Hz resonance point. Dr. Rebecca Morrison is now standing next to Samuel, looking at his phone. Her eyes widen. This is actually rigorous data collection. Where did you learn to do this analysis? MIT OpenCourseWare, online courses in materials science and mechanical engineering, and 8 years rebuilding engines with my father. Whitmore's voice comes from above again, desperate now, angry. Dr. Vasquez, I cannot allow... Dr. Vasquez cuts him off. Her voice rings across the demonstration floor. Mr. Whitmore, sit down and be quiet, or I'm leaving and taking my analysis with me. The entire room holds its breath. Nobody talks to Richard Whitmore like that. Whitmore's face goes red, but he says nothing. Dr. Vasquez turns back to Samuel. If your diagnosis is correct, what's your solution? Samuel takes another breath. This is it. Everything depends on the next 30 seconds. Two-part fix. First, recalibrate the AI pulse frequency to 418 Hz. That creates harmonic isolation from the mechanical cycle range. Second, install dampening buffers at the coupling assembly mounting points to absorb residual vibration. Total repair time 90 minutes. No disassembly required. The room erupts in murmurs. Engineers talking over each other. Emma Wilson speaks up. That's actually elegant, if the diagnosis is right. Christopher Davis looks torn. But implementing AI frequency changes requires deep access to the core architecture. It's extremely complex. One mistake could permanently damage the system. Samuel meets his eyes. I know. I've studied the codebase. I know it works. How? The technical documentation was in a wastebasket outside the engineering bay 6 months ago. I read all 1,238 pages while emptying trash. Stunned silence. Dr. Vasquez looks at Samuel for a long moment. Then she turns to the room. Here's what's going to happen. Mr. Underwood is going to implement his solution under my supervision. Mr. Davis, your engineering team will observe and verify every step. If he's wrong, we've lost 90 minutes. If he's right, we've saved this company. Whitmore's voice is desperate now. Dr. Vasquez, I cannot allow an unqualified maintenance worker to... Then save your $150,000. I'll leave right now. Your choice. The longest 10 seconds in Richard Whitmore's life. Finally, he speaks. His voice is barely above a whisper. Proceed. The demonstration floor transforms into a theater. 85 people form a semicircle around the Apex 8 system. Investors tune in via live stream from the observation deck. Media cameras position themselves for the best angles. Samuel Underwood stands before the main control console. Dr. Elena Vasquez is beside him. Christopher Davis and his engineering team watch from 3 feet away, tablets out, ready to verify every move. Emma Wilson has brought specialized monitoring equipment, thermal cameras, vibration sensors, stress analyzers. Every metric will be tracked in real time. Whitmore watches from the observation deck, arms crossed, face unreadable, somewhere between hope and fury. Samuel's hands are steady now. This is what his father trained him for, not the pressure, not the audience, but the work itself. The work always speaks truth. Dr. Vasquez addresses the room. Mr. Underwood will demonstrate his analysis in 3 phases: diagnostic proof, software implementation, mechanical correction. Each phase will be verified independently. She turns to Samuel. Whenever you're ready. Samuel approaches the main coupling assembly. He doesn't touch it yet, just observes. His eyes move across the components with the focus his father taught him. Christopher Davis steps forward. Before you touch anything, walk us through the failure mechanism. Prove you understand this system. Samuel nods. He points to the coupling assembly. The Apex 8 uses quantum sensing feedback to adjust torque in real time. The AI samples positional data at 400 Hz and sends correction pulses to servo motors at the same frequency. He indicates specific components. This coupling translates rotational force from the primary motor to 6 secondary articulation arms, designed to handle 15,000 Newton-meters of torque. Bradley Hammond interrupts. That's all in the specifications. Tell us something we don't know. Samuel moves to a diagnostic terminal. His fingers fly across the keyboard. He pulls up operational logs from the past 90 days. Notice this pattern. He highlights specific entries. Every failure or anomaly occurs when the system processes tasks requiring 11,200 to 13,800 Newton-meters. That's the exact range where the mechanical response frequency shifts to match the AI control frequency. He displays a graph. At 12,500 Newton-meters, the coupling assembly naturally oscillates at approximately 400 Hz. This is determined by the titanium-aluminum alloy composition, the geometric configuration, and the mounting point spacing. Dr. Rebecca Morrison leans in to study the data. You're saying the material properties create a natural resonance frequency? Exactly. When this aligns with the AI's 400 Hz pulse rate, you get synchronization, constructive interference. Samuel pulls up another screen. Each AI pulse amplifies the mechanical vibration by approximately 3%. Each vibration cycle feeds back into the quantum sensors. The AI interprets this as position error, sends correction pulses, which amplify the vibration more. It's exponential growth. Emma Wilson is taking notes rapidly. And the failure at minute 43? Samuel runs a simulation. His own code. Python script he wrote at home. At minute 43, the accumulated resonance stress exceeds the coupling's structural tolerance. Catastrophic failure. The simulation shows exactly what happened in the demonstration. The progressive buildup, the sudden collapse. Minute 43 on the dot. Christopher Davis stares at the screen. Where did you learn to write simulation code like this? Online courses, practice. I built a software replica of the Apex 8 control system at home using the documentation. Tested it against open-source physics engines. Bradley Hammond's face is red. That's our proprietary system. You had no authorization. Dr. Vasquez cuts him off. He used publicly discarded documentation to teach himself. That's called initiative. Continue, Mr. Underwood. Samuel brings up historical data. This problem started 6 months ago, when you updated the AI firmware to version 3.2. The update changed the pulse timing algorithm, made it more aggressive. That's when the resonance issues began. Emma Wilson checks her records. He's right. Version 3.2 deployed exactly 6 months ago. Dr. Rebecca Morrison speaks quietly. We dismissed the vibration reports because they were within spec, but we should have investigated the correlation with the firmware update. Samuel nods. The system isn't broken. It's a timing mismatch between AI and mechanics. Replace any part. The new part will fail identically. Christopher Davis looks at Dr. Vasquez. The analysis is sound. The logic is airtight. If he's correct, we've been trying to fix the wrong problem. Dr. Vasquez turns to Samuel. Phase 1 complete. Diagnostic proof established. Proceed to Phase 2. Samuel sits at the engineering workstation. I need Level 4 security access to the AI core control parameters. Christopher Davis hesitates. That requires executive authorization. Dr. Vasquez enters her credentials without hesitation. He has mine. The core architecture opens. Thousands of lines of code. Python with custom tensor libraries. The heart of the Apex 8 intelligence. Bradley Hammond steps closer. Changing the control frequency isn't simple. The entire system is optimized around 400 Hz. Change that, you risk destabilizing every operational parameter. Position accuracy, response time, energy efficiency, everything. Samuel's voice is calm. Not if you understand the dependencies. He navigates through the codebase with stunning confidence. No hesitation. He knows exactly where everything is. The 400 Hz frequency is set in the primary control loop here. He highlights the code, but it cascades through 51 other functions. If I simply change this value, 26 subsystems will misalign. His fingers move across the keyboard. Fast, precise. He's done this 100 times at home. First, I adjust the sensor sampling rate to 418 Hz. He modifies the quantum sensor interpretation algorithm, adds interpolation functions at specific points. Dr. Rebecca Morrison is reading over his shoulder. You're maintaining the effective resolution while reducing the pulse frequency, using predictive buffering to fill the gaps. That's actually brilliant. Second, the torque calculation matrices need updating. Samuel opens another module. The force distribution algorithms assume real-time feedback at 400 Hz. At 418 Hz, there's a 4.3% timing offset. I'm compensating by adjusting the prediction model coefficients. He works for 30 minutes. Every modification is clean, documented, explained. Emma Wilson is monitoring the code changes on a secondary screen. His modifications are integrating perfectly. No conflicts, no errors. Samuel finishes the core changes. Then he does something unexpected. He opens the energy management module. The frequency change actually improves efficiency. The 418 Hz pulse rate has better harmonic alignment with the power supply frequency. You'll see a 6 to 8% reduction in energy consumption. Christopher Davis checks the calculations. He's right. This is actually an optimization. Bradley Hammond is silent now. His face shows grudging respect mixed with embarrassment. Samuel completes the final modifications. Ready to compile? Dr. Vasquez nods. Proceed. Samuel hits compile. The code processes line by line, function by function, 0 errors, 0 warnings, clean compilation. He deploys the updated firmware to the Apex 8 system. The upload takes 3 minutes. Everyone watches the progress bar in complete silence. Upload complete. System reboot initiated. The Apex 8's displays flicker. The AI comes back online, new firmware active, operating at 418 Hz. Emma Wilson runs verification tests. Code integrity confirmed, all subsystems aligned, no conflicts detected. Dr. Rebecca Morrison is shaking her head in disbelief. The modifications are cleaner than our original architecture. He didn't just fix it, he improved it. Christopher Davis turns to Samuel. Where did you really learn to code like this? Online, free courses, practice, and 8 years of understanding how systems work together. Dr. Vasquez places her hand on Samuel's shoulder. Phase 2 complete, software recalibration successful. Proceed to Phase 3. Samuel approaches the coupling assembly with a toolkit. For 14 months, he's watched engineers work on this system, but he's never touched it himself, until now. Bradley Hammond watches skeptically. Those mounting points are precision engineered, tolerances measured in microns. You can't just install dampeners without complete recalibration. Samuel examines the assembly. His hands move with his father's confidence, the muscle memory of 1,000 engine repairs. The mounting points here, and here. He indicates 3 specific locations. These are where the highest amplitude vibrations occur. I install dampening buffers at these points. Silicone composite material with specific durometer hardness, tuned to absorb vibrations in the 380 to 420 Hz range. Won't affect lower or higher frequency operations. Christopher Davis frowns. Where are these buffers? We don't have those in inventory. Samuel pulls 3 small components from his backpack. They're perfectly machined, professional quality. I made them, 3D printed the housing, filled with custom mixed silicone compound. Tuned the resonance absorption profile specifically for this application. Emma Wilson takes one, examines it. The build quality is exceptional. What printer did you use? A salvaged Prusa I rebuilt, runs in my apartment. Samuel begins installation. First mounting point. He removes the existing bolt, inserts the dampening buffer, reinstalls with exact torque specification. 85 Newton meters, verified with a calibrated torque wrench. As he works, he explains, the goal isn't to eliminate all vibration, that's impossible. The goal is to disrupt the resonance pattern. These dampeners introduce phase delays and amplitude reduction at the critical frequency range. His hands work with surgical precision. Every movement economical, confident. This is what his father trained him for. Second mounting point. The room watches in absolute silence. Even Whitmore has moved to the observation deck window, watching intently. Third mounting point, complete. Samuel steps back. Mechanical dampening installed. Combined with the frequency isolation from the AI recalibration, the system should now operate safely across all torque ranges. Emma Wilson positions sensors around the coupling assembly. Let's verify. They power up the system. The Apex 8 hums to life. Initialization sequences run. Diagnostic subroutines complete. Status monitors display. Asterisk AI control frequency, 418 Hz. Stable. Asterisk mechanical response frequency, 398 to 402 Hz. Normal range. Asterisk harmonic coupling index, 0.03. Safely below critical threshold. Asterisk coupling assembly temperature, normal. Asterisk vibration, amplitude, 42% reduction from previous levels. Christopher Davis stares at the readouts. Initial diagnostics are perfect. Dr. Rebecca Morrison runs additional tests. The dampening is working exactly as predicted. Samuel's voice is quiet. Run the same demonstration sequence that failed. Full torque. Through the critical range. Emma Wilson looks at Dr. Vasquez. That's the real test. Dr. Vasquez nods. Do it. Christopher Davis initiates the full demonstration program. The same sequence that catastrophically failed 6 hours ago. The Apex 8 engages. Robotic arms extend. Quantum sensors activate. AI control systems come fully online. A turbofan engine component positions for assembly. The operation begins. Everyone holds their breath. The Apex 8 moves through its sequence. Minute 1, minute 5, minute 10. Every movement is fluid, precise, perfect. Samuel stands beside Dr. Vasquez. His heart is pounding, but his face stays calm. He's done everything he can. The work will speak for itself now. Minute 15, 20. The system enters medium torque operations. This is where minor anomalies began appearing months ago. Emma Wilson watches her vibration monitors closely. Amplitude is stable. 40% below historical levels at this torque range. 25 minutes. 30. The system approaches the critical zone, 11,000 Newton meters, where everything started going wrong. Christopher Davis's voice is tense. Entering critical range, 11,500 Newton meters. The room is absolutely silent. 85 people frozen, watching screens, watching the robotic arms, listening for any sound of failure. 12,000 Newton meters. This is it. This is where the resonance pattern killed the system before. Samuel watches the harmonic coupling index, 0.03, steady. The frequency isolation is working, 12,500 Newton meters, the exact point where catastrophic failure occurred. In the previous demonstration, this is when alarms blared, when sparks erupted, when metal started screaming, when everything collapsed. Now, the Apex 8 operates smoothly. No vibration spikes, no temperature anomalies, no resonance buildup. The coupling assembly stress levels sit comfortably within safe parameters, 13,000 Newton meters, 13,500. The system passes through the entire critical range without incident. Dr. Rebecca Morrison is staring at her screen with wide eyes. Harmonic coupling is holding at 0.03. We're stable. Emma Wilson's voice cracks slightly with emotion. The dampening is working perfectly. Vibration is absorbing exactly as predicted. 35 minutes, 40 minutes. The system continues working. Minute 43 arrives, the exact moment when everything exploded before. Nothing happens. The Apex 8 continues its precise assembly operations. Smooth, controlled, perfect. The turbofan component is nearly complete. 132 precision operations, each one executed flawlessly. Minute 48. The sequence completes. The component is finished. Christopher Davis moves in with measurement tools. He checks dimensional accuracy at 16 critical points. His hands are shaking slightly as he reads the results. Dimensional accuracy within 1.8 microns. That's better than our baseline performance before the failure. Dr. Rebecca Morrison runs system diagnostics. Operating efficiency is up 12%. The frequency optimization reduced control lag. This is actually performing better than the original design. Someone in the back starts clapping, then another person. Within seconds, the entire demonstration floor erupts in applause. Engineers, operations staff, maintenance crew, administrative personnel, everyone is clapping, cheering. Samuel stands there, overwhelmed, tears threatening to blur his vision. He blinks them back. Dr. Vasquez extends her hand. Mr. Underwood, in 30 years of consulting, I have never seen a more elegant solution to a complex systems failure. You didn't just fix this system. You improved it. Samuel shakes her hand. His voice comes out rough. Thank you. Christopher Davis approaches. His face shows genuine remorse. Samuel, I owe you an apology. We should have listened months ago. I'm sorry. Bradley Hammond stands off to the side, arms crossed, face red. He can't deny what just happened, can't argue with the data, but his pride won't let him approach. Emma Wilson is grinning. That was the most impressive diagnostic and repair I've seen in 15 years in this industry. Dr. Vasquez turns to the room. Run it again, but this time push it to 110% of rated capacity. I want to verify the stability extends beyond original specifications. Christopher Davis looks uncertain. That exceeds design parameters. If Mr. Underwood's solution is truly sound, the system should handle it. If there's hidden instability, we need to know now. Samuel nods. Run it. The second test sequence initiates, this time pushing the system harder than it was ever designed to go. Maximum torque, 16,500 Newton meters. The Apex 8 handles it perfectly. Not only stable, but efficient. The resonance solution didn't just fix the problem, it unlocked performance that was always there but artificially limited. Final diagnostic report displays across every screen. Asterisk harmonic coupling index, 0.02. Improved. Asterisk coupling stress, 66% of maximum rated. Safe margin. Asterisk operational efficiency, plus 14% compared to original baseline. Asterisk thermal performance, plus 9% improved. Asterisk positional accuracy, plus 0.4 microns. For 3 seconds, there is perfect silence. Then the demonstration floor explodes with celebration. People cheering, hugging, some crying with relief. The company is saved, jobs are saved. 300 families won't lose their income, all because someone finally listened to the maintenance worker. Everyone turns to look up at the observation deck, at Richard Whitmore, the CEO who dismissed Samuel, who threw his tablet in the trash, who called him boy and threatened his mother's job. Whitmore stands at the window. His face is unreadable, a complex mixture of relief, humiliation, and something that might be the first seed of shame. He makes no move to come down, no move to apologize, just stands there. Watching the celebration he has no part in, Dr. Vasquez's voice cuts through the noise. Mr. Davis, prepare a full report for the investors. The system is operational. The crisis is over. She turns to Samuel. You and I need to talk about your future. If this moment gave you chills, hit that subscribe button, because what happens next will show you what real justice looks like. 2 hours later, the main conference room. Samuel sits at a table with Dr. Vasquez, Christopher Davis, Dr. Rebecca Morrison, Emma Wilson, and 2 investor representatives via video call. Whitmore is notably absent. Dr. Vasquez speaks first. We need to discuss Mr. Underwood's position at this company. Christopher Davis nods. I'd like to formally offer Samuel a position in our engineering department. Senior Associate Engineer, full project access, direct pathway to lead engineer within 2 years. He slides a paper across the table. Starting salary, $95,000 annually, full benefits, education reimbursement for degree completion, stock options. Samuel stares at the number. $95,000, more than 5 times his current wage, more money than his mother makes in 2 years of cleaning offices. But Dr. Rebecca Morrison speaks up. That's generous, Christopher, but insufficient. She addresses Samuel directly. I've been authorized by our aerospace division to offer you a lead research position. You'd work directly with me developing the next generation system. Salary, $120,000. Accelerated pathway to senior engineer. Samuel's head is spinning. These are life-changing offers. Either one would transform everything. Then Dr. Vasquez speaks. With your permission, Samuel, I'd like to make a different proposal. She leans forward. I'm establishing a new consulting division, focused on solving impossible systems integration problems. I need someone with your unique perspective, someone who understands both theory and practical reality. I'd like you to join as a co-founder and principal consultant. Starting salary, $140,000 plus profit sharing. We'd work together solving challenges for companies worldwide. She pauses. And I'd personally sponsor your master's degree education. Full scholarship through MIT's distance learning program. You'd earn your credentials while gaining real-world experience. Samuel can barely breathe. Why? Dr. Vasquez's voice is firm. Because this crisis proved something I've known for 30 years. Credentialed experts miss things. We need voices from unexpected places, your voice specifically. She extends her hand. This is about more than one company. This is about changing how the industry thinks about talent and expertise. Samuel looks at the offer, thinks about his father, about his mother cleaning offices, about every door that was closed in his face. He shakes Dr. Vasquez's hand. I accept. The celebration dies down. The investors are satisfied. The media has their story. The crisis is over. But something else is beginning. Something that Richard Whitmore doesn't see coming. Within 48 hours, the TechVantage Board of Directors initiates an internal investigation. Not about the system failure, about the management decisions that led to it. They pull records, review emails, interview staff. What they find is damning. Samuel submitted 6 detailed maintenance reports over 14 months. Each one contained critical observations about system anomalies, vibration patterns, thermal irregularities, behavioral warnings. Every single report was dismissed or ignored by engineering leadership. The report from 6 months ago specifically identified harmonic vibration in coupling assembly C4 during high-torque operations, the exact failure mechanism. Bradley Hammond crumpled it without reading it, told Samuel to stick to mopping floors. The email Samuel sent 2 weeks ago contained thermal imagery and diagnostic data. If reviewed, it would have prevented the catastrophic failure. but Hammond had implemented an email filter specifically blocking maintenance personnel from contacting engineering staff directly. The investigation calculates the cost of ignoring Samuel's warnings. Asterisk emergency consulting fees, $850,000 asterisk, stock value loss, $680 million in market cap asterisk, delayed contracts, $120 million in immediate revenue, asterisk, reputational damage, incalculable asterisk, legal exposure, potential shareholder lawsuits, nearly $800 million in direct and indirect costs, all preventable if leadership had listened to an $18 an hour maintenance worker. The board calls an emergency meeting. Bradley Hammond is terminated for cause, specifically for implementing communication barriers that prevented critical safety information from reaching decision-makers. His career in the industry is effectively over. His LinkedIn profile receives no responses from recruiters. Christopher Davis receives a formal reprimand and mandatory management training. He keeps his position, but his reputation is damaged. Then the board turns it to Richard Whitmore. They give him two options: resign immediately with a severance package, no public disclosure, or remain as CEO under 90-day performance review. But if he chooses to stay, the board releases a full report documenting his role in the crisis. Whitmore's pride chooses option 2. He believes he can weather the storm. He's wrong. The story goes viral. Tech journalism loves this narrative. Maintenance worker saves tech company after CEO ignored warnings for months. LinkedIn posts explode. Industry forums discuss the case. A shareholder lawsuit is filed citing negligent leadership. Major corporate clients express concerns. TechVantage's largest client, an aerospace manufacturer representing 30% of revenue, sends a letter. We have concerns about leadership culture. Unless changes are made at the executive level, we will reconsider our partnership. 3 other major clients send similar messages. Day 62 of Whitmore's review period. The board meets again. The vote is unanimous. Richard Whitmore is removed as CEO, terminated for cause. Gross negligence in safety protocol adherence and creating a hostile work environment that endangered company operations. No severance package, no golden parachute. His job search is difficult. His reputation precedes him. The man who nearly destroyed his company because he wouldn't listen to a black maintenance worker. Eventually, he finds a position. VP of Operations at a mid-tier manufacturing firm. Salary $180,000, less than half his previous compensation. His new office is in a building where Samuel's mother, Margaret, works as a contract cleaner. The first time he sees her emptying a wastebasket, she looks at him directly, says nothing, but the recognition in her eyes is clear. He looks away first. 1 year later, Samuel Cooper stands in MIT's auditorium, receiving the Distinguished Early Career Engineer Award from the American Society of Mechanical Engineers. He's completed 18 months with Vasquez Consulting, solved impossible problems for companies across 3 continents. He's halfway through his master's degree, been featured in Wired, IEE Spectrum, and Fast Company. But tonight, presenting his award is Dr. Elena Vasquez, and sitting in the front row is his mother, Margaret, no longer cleaning offices. Samuel's salary allowed her to retire 6 months ago. Before accepting the award, Samuel speaks into the microphone. My father taught me that the work speaks louder than the title. Tonight, I want to add something. Sometimes the work speaks so loudly that no one can ignore it anymore. The audience stands. Applause fills the auditorium. This is why we never count anyone out. Why we listen to every voice. Why credentials matter less than competence. Drop a comment. Tell us about a time you saw something everyone else missed. Share this story with someone who's been underestimated. Subscribe for more stories where talent triumphs. Remember, the next breakthrough might come from the person everyone overlooks.